Good morning, seventh graders, or afternoon, depending what time you are watching this. Okay, so today's objective is that I will solve and check two-step equations with rational coefficients. We're going to look at a specific type of rational with using distributive property. Remember, we did these back in, I want to say November, with expressions. We had distributive property with expressions. And this was kind of like if we had day equals, let's keep it lowercase, plus baby. Right? You take your b times everything inside the parentheses, and that makes this new expression. Okay, we're going to focus on modeling it today. So if you have your textbook, you want to open it to page 477. Okay, so we're at page 477, where we're going to be modeling today. So this first one is inquiry lab. That means we're going to be practicing and putting in some information. The first one's a word problem. Mark has two summer jobs. He babysits and helps with the gardening. He works at each job 3 days a week and earns a total of $240. The table shows his earnings each day. How much does he earn each day babysitting? So we have a table. Okay, here we don't know how much he makes right now for babysitting each day, but we know for gardening he makes 30. And throughout the whole week, the 3 days he worked, made $240. Okay, so what do we know? We kind of just went over that. We know, let me get my text back, that gardening daily equals the $30. And we know total week is $240. And he works 3 days. What do we need to find? Well, the amount earned each day from babysitting. That's what we're trying to find. That's what our variable represents. So when you're given word problems and they say define the variable, that's what goes after what your variable is. So here we have a bar graph. Okay, it is split into thirds because Mark works 3 days. And this is the expression that goes inside each 3 days he works. He does gardening, he does babysitting. We know this whole time he is making $240. Okay, so we're going to look at each step. So if we have an equation that is modeled by the bar diagram, so we have 3 times something for babysitting plus his gardening. And how much did he make? $140. Okay. From the diagram, you can see that the 1/3 of Mark's total earnings is equal to x plus 30. So x plus 30 is whatever 240 divided by 3 is, which is $80. Okay, that means he's making $80 a day. So then our next part here, oops, move it down. We're going to fill it in. Mark earns $80 minus the 30 from the gardening. So how much is he making each day for babysitting? Is $50. And make sure you have that filled in, and then we're gonna flip over to 478. Okay, that's one way to model. Okay, this one is another way to model. It gets a little bit different. I want to go completely full page. Okay, so Vijay and his brother bought 2 hamburgers and 2 lemonades. The hamburger cost $6 each, and they spent a total of $16. How much did each lemonade cost? Okay, so if we were to write an equation for this, that would be our equation. Okay, so $6 each is important. The fact that they got 2 hamburgers and 2 lemonades tells me that our number out here has to be a 2. And they spent a total of 16. So that's how we know it equals 16. Okay. Well, and the hamburgers were $6. So that's why we have a 6 there. Using the algebra tiles, we are going to split it into 2 groups. Okay. So if you see, they have it modeled. We have 2 groups of X and 6 ones. Just like if we were to put our pluses, our positives, or negatives here. Okay, then on the other side is their 16. So that's what it represents. We need to divide the tiles into 2 equal groups. And then we're going to remove them. So we have the top group, the bottom group. Split 16 in half. And we're actually going to ignore the top section now. So we want to keep 1 group and remove 1. That leaves us with just our x plus 6 equals 8. Now, if this was a one-step equation that you were trying to solve and model, what do we have to do with these 6 positives? We have to get rid of them, right? And if we get rid of these 6 positives, we have to get rid of 6 positives over here. Same process. Okay, so whatever's left over tells us what this 1x is. So we would say x equals 2, and because it's a word problem, we need to answer with a full sentence. Each lemonade cost $2. All right, we're going to flip over to the next page, 479. There's a couple, about 6 examples there to do. Okay, so we're at the top of the page of 479. We have 3 times x plus 5, and that equals a 21. So what does that tell us? Well, I need to know. Let me go back to a pen here. We know now that this, whoops, why did it let me go? This whole bar here, how much is that going to equal? It equals my 21. Okay, how many parts do we need? Well, we need 3 parts. So the best you can, make it into thirds. What goes inside each of these parts? Our x plus 5. Okay, we could break it down even more now. How much is just this one part worth? If you made $21 for 3 days worth of work, how much did you make in one day? 7, right? So if that one little section here makes $7 and we took 5 away, how much is left for x? 2. That's a really bad 2. Erase some of it. That looks a little bit better. Okay. See if you can try the next one. Think about, what does the whole thing equal? whole thing is a 10. Okay. How many parts do you need? 2. What goes inside each part? X minus 3. X minus 3. Okay. How much is each part? Well, this part here is 5 because that's half 10. That's how I got that. Now, I'm not taking away 3 anymore. I'm actually going to add 3 to it. So then I get that x equals 8. Okay. We're going to go down to the bottom. We have some more examples. Okay. Now this can get really messy real quick. Okay. Because you got to think about, it tells us we have 4 parts. Okay, so I technically now am going to go ahead and plan ahead. I know I need 4 parts. 1, 2, 3, 4. Okay. Inside each part, I get an X. And a 1. 1, 1. Or you can put positives, since eventually we're going to have negatives. And then I'm going to split my 8s. Okay. So I have 1, 2, 3, 4, 5, 6, 7, 8. Now this is where it can get messy. So see these parts here? I'm going to ignore these sections. Oops. Right there. I'm only going to focus on this bottom section because I only want to know what 1x is. Okay. So then what's the opposite of a positive 1? Minus 1, right? Minus 1. Oops. I put too many minuses. Remember, however many you put over here, you got to put over here. So then what am I left with? Well, we're only left with a 1. So that's what x actually equals. Okay. All right, let's look at number 4. I'm going to split it into 3 sections. 1, 2, 3. Inside each section is an x and then plus 2. I'm going to just put positives now. Then I need to split 12 negatives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. I am only going to focus on this section right here. The other sections we are going to basically ignore. Not focused on those other 2 sections right now. You can shade them out if you wish. All right, so then I have x and 2 positives. And how do we get rid of positives? What's the opposite? I know you're shouting out while you're watching this. A negative, Mrs. Oliver. Now, remember, only a positive and a negative can cancel. So on the right side, do I have anything I can cancel? No. I just got to count how many negatives I have, and that is 6. So x equals 6. Moving along to number 5. Split it into 2 groups because it told me there's 2. Then each one gets an x. And then each gets a negative 1. But the other side, I'm going to split the 6 between them. 1, 2, 3, 4, 5, 6. Now remember, we're going to ignore everything but one section because we only want to know what this 1x is. Okay, what's the opposite of a negative? A positive. Those cancel. And then all I'm left with is how many do I have left here? 1, 2, 3, 4. X equals 4. All right, feeling confident, try number 6 on your own. Otherwise, keep watching me. Each gets an X. And then 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And split your -3s. That's why we don't just automatically start with only one section, because we don't know how many is going to go into each one. What if we have a super large number? Alrighty, magic paintbrush. Let's go with pink this time. I'm going to paint this one out. Don't care about it. Okay. Now I gotta get rid of my 4 negatives on the left side. So that means I'm going to add 4 positives. Because I did 4 positives there, how many positives do I need to put on the right? 4. Okay, these cancel, and so does that pair. So all I'm left with is 3 positives, and that's your solution. Okay, as long as you know what you're looking for and you keep going in a little time, don't rush through it, you're going to turn out just perfectly fine doing them. Okay, and then there is some analyze and reflect. Okay, go ahead and do your analyzing. Fill that in. Okay. Model. So that is your exit ticket. So make sure you get those taken care of. Okay. You guys have a great day, and make sure you keep getting your assignments turned in on time so you can get your feedback on time.